Okay, I got a great question from a student here. It's one of these interactive problems, and they sent their best guess on how to handle this one because it's got a lot going on the inside layer of this, the 2x plus 6y, or 6 pi. So I'm going to offer some instruction to them specific to their guess here with where they've got the green points, and we'll go through the correct way to do that. But as I get started, I want to point out the difference in the way these parameters are handled in a lot of textbooks, in Khan Academy, and other resources out there to how we're doing it together in our class, which I think is much simpler when you look at the difference between what I've been calling this f value, which in this case is 6 pi, and how we want to handle it, which is with this phase shift we can see here, x plus c separated out. There's just a little workaround in order to get it into this mode, and here it is. You could calculate c by factoring the b value rather, out of the f value that you're given. So I'm using f instead of c when you just get this expression here, 2x plus 6 pi. I'm calling that 6 pi the f value. So what we're going to do is take the f value of 6 pi. Well, I'm going to do one better. Let's just write the formula out first. What am I actually doing here? What we want to do is multiply whatever that constant that I'm calling the f value times the reciprocal of b. Okay, so here's what that's going to look like when we execute that. This will be 6 pi. And the reciprocal of b is 2 in this case. That's just the 2 value out front of the variable x. So multiply by the reciprocal of that is 1/2. And we will get a c value, so that'll be 6 pi over 2 when you combine that multiplicatively. And that'll reduce to just 3 pi. So what you're going to see me do now is rewrite this f of x model with all the parameters that we have from this function that they give us. And here it is. You know, because the a and the d and the b all are the same. It's just that c and f value we have to kind of fiddle with in order to see phase shift. So now that we've got this, I'm going to have the layered parentheses in here. We clearly have an a value of 3, so we know our amplitude. Looks like the student did well on that part, as well as the +4 for the midline. Also did great there. The b value is that 2 we mentioned. We've already used that. And then the innermost layer, that's where we had to go calculate this c value, and it's positive 3 pi. So I'm just going to kind of diagram with words here. Amplitude of 3, midline of positive 4, okay, and you can see that on the graph here going right through the middle of that wave. That looks good. Next, I'm going to talk about that phase shift. This is a phase shift left 3 pi. So I'll just say that in words. Phase shift is a horizontal shift left, because we're adding 3 pi units. Okay? And so we'll be tracking our anchor point with that phase shift. And then the last thing I'll mention is the b value there of 2 is going to give us a period length. Remember, we can calculate this quickly. I should maybe just use a little space up here. Okay. Period is equal to 2 pi divided by the b value. So in this case, we're going to get 2 pi divided by 2, which is just going to be pi. So the period is pi. All right. Now, on the topic of period, while I'm thinking about it, that's one period. What we're interested in is the spacing between these two green dots. Okay? They need to be not a full period apart, but a quarter period apart. Okay. So if I know what one full period is, then finding a quarter period is actually pretty easy. You just divide by 4 to scale that down. So dividing by 4, I'll get pi quarters for the spacing between those two dots. And really, I'm going to set up a new axis because I think it's getting a little bit crowded on that one. So bear with me here. All right, well, that didn't work. Let me try that again. All right, so I'm going to stick with the scaling they have. They're going to, up here, they're going by pi radians. And so I'm assuming you can snap to not just the pi half radians, but even the half step there, because that's where that green dot is going to have to go. However, I'm getting ahead of myself. We have not taken care of the phase shift. So this phase shift of things need to move left 3 pi is going to first alter this original dot that was placed up here. So this is going to be moved back to 3 pi, which is right here. So that's where the very first dot is, back at negative 3 pi. And I'm going to make my scale here, negative 3 pi, and that's at a height of 7. So 1, 2, 3, 4, 5, 6, 7. So right there, that's where that first green dot for that maximum should be. Okay, and then we had our midline, which I had in green originally, so we'll stick with that. Midline kind of going through 4 there. So I know my other dot is going to be on the midline, and it's got to be a quarter. Let me finish labeling this. This is negative pi, negative 2 pi, and I get as low as 1 on this. Okay, so this other green dot, I think it was using red here, but this other dot is going to have to be pushed over, so it's just a quarter step away. So a quarter pi step, you're really going to have to parse this down and cram that dot right in there. Okay, and that's going to be a pretty squished picture now. The graph will start to fill in and wireframe itself into this really steep, horizontally compressed cosine function, and it'll populate the whole screen for you. But that's where your second dot is going to have to land. And I'll try to place it up here. It would be right there. So maximum dot there and midline dot right there because of our phase shift and our shrunken period, horizontal shrink there. All right, I hope that helps. Let me know.